Grant, good luck.
Thank you.
Grant, did you find it? Does everyone have one? Otherwise, I have a blank one. This doesn't have the first half on it. All right. So technically, this is where 11.2 starts, and that's the formula for the area of a trapezoid. So we have trapezoid here. Now this also includes an isosceles trapezoid. So this isn't just the one trapezoid. Any kind of trapezoid uses the same formula. Now, if for some reason you totally forget the formula for a trapezoid, you won't have to memorize it because it'll be on the exam, which means you get to make a note card. But if you were ever in a situation where you need to know the area of a trapezoid, you could also divide a trapezoid up as like two triangles and a rectangle. So just understanding that a trapezoid is just made up of basically three shapes. You know how to find the area of triangles, you know how to find the area of a rectangle. Typically, you'll probably have enough information that you could do that if you needed to. But there is a formula. It's kind of a little bit of a shortcut, but if you ever got confused about the formula, you could just break it up into those three shapes. So I will show you guys that formula, and this is probably not one maybe you know off the top of your head, but it might seem familiar once you see it. So it's base 1 plus base 2 times the height. Show you guys another way you can see it. Either one is fine. So either of those, they mean the same thing. So the B1, B2 is the bases. So the bases of our trapezoid. Remember, the bases are parallel. So if you're ever unsure about which one the bases are, they're always the parallel sides. Then the height, remember, just like the base and height of a trapezoid or of a triangle, the base and the height have to be perpendicular. So the height is typically inside the trapezoid, and it's always going to be perpendicular to that base. So I just wrote B is perpendicular to H. And if my camera's in the way at all, feel free to move around it or stand up. So that's one of our new formulas here today. And again, good news is you don't have to memorize it because you'll get to make a note card for the exam. The last one is a kite and a rhombus. Now, if you recall, we actually talked about a rhombus up above. So depending on the situation, sometimes a rhombus you can use base times height. But if you don't have that information, you might also be able to use this. And I almost always forget about this, to be honest. Out of all these formulas, for whatever reason, I would not know them unless I really have to dig back in my memory unless I'm in the chapter. I forget about this formula all the time. I even keep looking at it and make sure I have it right. So it's D1 times D2, that should be a little dot there. Divide by 2. Or just 1/2 D1 times D2. And the D1 and D2 are the diagonals. So in the case of a rhombus, if you know the diagonals, you can use this formula. Yep. Yeah. If you know the base and height, you want to use the other formula. So this is a rhombus, kind of a a skew one here. So the D1 and D2 would be going across the middle, and remember they're always perpendicular. So we'd have to remember that piece of it. So D1 is, perpendicular to D2. D1 is perpendicular to D2. Now down here, I just wanted to really quick remind you guys, if the rhombus looks like this, again, if you know the diagonals, that's fine, but remember, you can also use, that should be base times height divided by 2. Or base times height just for, so that's an alternate for a rhombus. So this also works for a rhombus, but it just depends which situation you have. So we essentially have 2 formula for rhombuses. All right, so if you guys want to flip to the examples we haven't done yet. So that's example 3, I think is the first one. They tell us this is a trapezoid. So we want to find the area of the trapezoid. This one's pretty straightforward. They really give you everything you need to find that area of the trapezoid using that formula. So our area of a trapezoid formula, B1 plus B2 divided by 2 times the height. Now, if you're doing this one, just to remember, B1 plus B2 is kind of like it's in parentheses. When you have a big division bar like that, that's like a grouping symbol. If you want to take time to figure out if you guys know where B1 and B2 are and try to solve that one real quick. Or not real quick, or just in general. I'm going to do attendance. What is B1 and B2? Mackenzie, what did you get for B1 and B2?
18 and 40.
Yeah, so the bases are on the top and the bottom there of our parallelogram. So the 18 and 40 get added together. Now again, if it helps to put parentheses around that so you don't forget to do that, you're going to add it together first, then you're going to multiply by 2, then you're going to multiply by the height. And the height in this case is 15. So all the information's there for us, have all the pieces we need. So we have to add that first, so we get 58 divided by 2, and then multiply it by 15 to find our area. And it's meters, so it'd be meters squared. So 58 divided by 2 is at 29 times 15. Yeah. And then that's just meters squared. So they kind of give us all the information in that case, it's kind of be very straightforward. Now the next one is not as straightforward. They're asking for the area of a kite. Now a kite is, like I said, that's the one that for whatever reason, I have a really hard time remembering this one, just maybe because you don't use it very often, where I think some of these other ones maybe are a possibility. So the area of a kite, that formula is I multiply the diagonals together, and then divide it by 2. So I have to figure out what the diagonals are first. And this one doesn't tell me the diagonals. It tells me some parts of them. So to be honest, for the kite, they should really tell us that those two are equal and those two are equal. Obviously, you can kind of assume it based off of them telling us it's a kite. So do I know anything else about this? Is there anything right now that I can just see and use? Do I know either of the diagonals? Yeah, Katie?
The other side of 16 is also 16.
Yeah, so those are both 16. So I actually have the one diagonal. All the way across is going to be how much? 32. So I know one of the diagonals. It's called a D1, I know.
Would the other one be the left of that one, right?
Yeah, so now we're looking for
Oh.
this one, yeah. So we're trying to find this diagonal. But this line is kind of unknown to us right now, right? So how can we find that? Yeah, go ahead, Haley. Yeah, we can do Pythagorean theorem for this one because we want to find that little x there, and we know if this is a kite, the diagonals are perpendicular. So Pythagorean theorem comes up again here. So x squared and 16 squared equals 20 squared. If you haven't learned already, I really like those special right triangles, especially a 3, 4, 5 right triangle. This happens to be that. If I move that 16 squared over, I can already tell what x is going to be, but only because I'm comfortable with these. But so if I move that over, this is going to be 144. So x is going to be 12, skipping over a few steps there. So you squared each of them, you move that 16 squared over. So this ends up being 12 here. So that means I can find this diagonal. It's the whole way up and down, so 35 and 12. So that's going to be 47. So 35 and 12 together, that's my other diagonal. So careful though, because the kite's different than the trapezoid. Here we're multiplying, there we were adding. So we're multiplying these two together. So 32 times 47, and then we have to divide it by 2. So rather than adding, we're multiplying. And I get 752, I believe. And this again will be meters squared. We have a few more to finish up here. This is kind of similar to what we were doing as part of our homework today. It was basically, I probably could have actually done this with you guys yesterday, these are technically, I guess you could say they're technically trapezoids, but I don't know if we have enough information to use the trapezoid rule for them. So if this is a trapezoid, we don't know the one base. So what I'm going to have to do in this case is kind of make this into a rectangle and a triangle. So if I draw that there and I say that these are right angles, it's kind of a confusing idea that you can just draw that in. It's okay to do as long as we say those are right angles. We can assume that it's a rectangle there, which is kind of a strange thing that you can do in geometry. If this is a rectangle, those are all right angles. This has to be 21 and this has to be 20. This is the way a rectangle works. But I don't know this distance yet. But I should be able to find it because that's a right triangle there and I know 2 of the sides. And I actually think this happens to be a special right triangle, but this one would have been one I knew. Not one that comes to mind for me. 21. Now this one you kind of have your options here and how you guys want to solve it. Do you want to find the area using the trapezoid formula, or do you want to use a rectangle and a square, or rectangle and triangle? Here. What's that? Trapezoid? Alright, I'll go with trapezoid. I'm not hearing otherwise. Whoa, it's a little less to keep track of. So base 1 plus base 2. So here's base 1 is 21. Base 2 is this whole thing, which is 21 and 21, which is 42. Divided by 2, multiplied by the height, which is 20. So like I said, I feel like the trapezoid formula is a little more efficient than taking that as a rectangle and a triangle. And so we get 630 for this area. And they don't have units on this one, so you can just write 630. If you wanted to be really technical, you could say units squared. Sorry. But it didn't ask. All right, so this next shape is also a trapezoid. But, because we have the parallel lines, but if you notice, we're missing this height. But hopefully you guys notice that there's a parallelogram within this. So if that's 26, this is 26. If this is 40, this is 40. So all I'm missing in this case is the height again. Now, one of the things I do want to point out is if we're looking for the bases, this whole base is the whole top base, so that's going to be 50. This whole bottom base is 60. And then the height we're going to have to use Pythagorean theorem again. Like I said, this is a good chapter to end with just because it reviews the Pythagorean theorem so much, and it's definitely something we need to know. I move that 100 over, I get 576, and I take the square root of that. And that ends up being 24 for my h. So now we can do our trapezoid formula. Base 1 plus base 2 divided by 2 times the height. Hi. Alright. The last one's a little bit trickier. We'll finish up with this one and you guys have the rest of the time to work. You probably could go outside if you wanted to sit outside and work. I sent you by Mr. Carter's class because obviously you're talking to us too. All right, last thing here. So we have our area, but they want us to find x. They give us the area, they want us to find x. So hopefully you notice this is a trapezoid. Kind of a weird little trapezoid. This should probably be like little dotted lines here. So technically, the x again could be in here as well. So we have our base 1, we have our base 2, and they're giving us the area. So this is our formula. We're missing the height. So this becomes a big algebra problem. So our area is 108. our base 1 is 22. Our base 2 is 14. Divide by 2 times the height. I don't know what that is, but this we can kind of simplify a little bit and figure out we can solve for this. So 22 and 14 is going to be 36. Thirty-six divided by 2 is 18. So in order to solve for h, we're just going to divide by 18. So h is going to be 108 divided by 18, and so we find out our h is going to be 6. So 6 feet. Alright, so the second half of the homework is what's going to be due for tomorrow. I was going to say Monday. It is not Friday, even though it feels like Friday. So I will get that. That'll be due for you guys tomorrow. So that 11.2. I don't think it's online yet. So let me fix that. The 3 through 27 is due Friday. Can we go outside? Let me just check with Mr. Parker. I need to get something on I have to put that stuff on my computer. So. You guys, if you want to go out there, just behave. Otherwise, you're welcome to stay in. I'm staying in.